My name is Tai Nguyen, and my project is design a battery management system for fast charging of electric vehicles at high temperature. There will be about 120 to 230 million electric vehicles in the world by 2030. The current battery technology is vulnerable to high temperature. At high temperature, there are three common failure mechanisms: the loss of lithium inventory, and loss of the active material on the anode and cathode. The battery life and capacity decrease as its temperature is not managed appropriately. A cooling method is needed to better manage the temperature of the batteries during the fast charging sessions. There are many researches focused on the battery characteristic and the cooling optimization of the batteries during the fast charging. Xu said that the 7-type cooling channels has higher cooling capacity than the traditional U-shaped cooling channel. Kieser stated that heat generation in 10 minutes of fast charging can produce 50 kilowatts of heat. The objective of this project is to design a battery management system that monitors and controls the temperature of the lithium-ion batteries for electric vehicles under fast charging. The system will keep temperature uniformly distributed across the module. The temperature difference between the highest temperature and the lowest temperature must be under 10 degrees Celsius. The system will cut off the supply voltage to the overheated battery cell when the cell temperature exceeds 65 degrees Celsius to prevent thermal runaway. The first major deliverable is the review code for battery management system with a built-in PID controller. The second deliverable is prototype the cooling system that includes a pump, three-way valves, a battery module, and heat radiators. The third deliverable is a prototype of the temperature monitoring system that includes a physical setup of thermocouples and data acquisition device. The evaluation metrics of this project is the smaller temperature differences across the battery module in degrees Celsius. A PID controller must be developed to actively monitor and control the temperature of the battery inside the systems. A cooling system must be developed to control the flow rate of the cooling fluid inside the systems. The temperature monitoring system must be developed to accurately and precisely record the temperature data. And finally, a design of experiment must be conducted to test the capability of the systems. There are two phases in this project. The first phase is from August 2022 to December 2022, which includes the development of the PID controller, the development of the cooling system, and the development of the temperature monitoring system. The second phase is from January 2023 to May 2023, which focuses on the design of the experiment, conduct and analyze the result. There are two resource categories. The software categories include MATLAB, LabVIEW, Excel, which are provided by San Jose State University. The hardware categories include the lithium-ion batteries, the cooling system components, temperature monitoring system components, and electronic components. The first challenge is the supply shortage on the 7-type cooling channels. The contingency plans is to use air cooling as an alternative solution. The second challenge is the data acquisition device might not be provided by the ME department. The alternative solution is to use an open source data acquisition device such as Arduinos. Two ANSYS simulations was run with the same initial temperature on the battery and different convection heat transfer coefficients. The scenario with higher convection heat transfer coefficients has lower time to reach the steady states. A diagram of the cooling system was generated, which include a pump, two valves, battery module, and a heat radiator. A diagram of the temperature monitoring system was generated. There are 5 battery packs in the battery modules. Each battery pack had 2 thermocouples attached to it. The ANSYS simulation acts as a reference to choose the appropriate convection heat transfer coefficient for the system. This project is a contribution to the development of fast charging technologies, which reduce the battery temperature during fast charging sessions. It also accelerates the transition from the internal combustion engine vehicles to electric vehicles.